So let's get started. So first of all, let's see what is our agenda today is. So we are going to see what is Azure Data Factory is, and then we are going to look a bit about what are Azure Data Factory components, and then we'll do a small demonstration on how to build a dynamic data pipeline using Azure Data Factory. And for the introduction, as you all might know, we live in a world of big data these days. So everywhere we look, from our mobile phones, from websites, from even from our smart homes, smart light bulbs, everywhere we record data. So it's like internet has given access to so many things for us, and with that we collect so much data from our services, and that data can be from many formats, and they can be in raw unorganized data, and they can be relational, non-relational, or they can be in different database systems, or they can be in file storage. So how are we going to manage all this data? That is what we are going to look at today using Data Factory. So on its own, I don't think raw data makes much use for us. So raw data doesn't have a proper context, and it doesn't have any meaning to give us proper insights. So using big data, we can run some queries, and we can orchestrate and operationalize some processes to refine these enormous data and make them useful for us, those raw data. And they can be used in so many scenarios. We can use them to take actionable business insights. We can see how we can improve our SaaS or other services. So raw data on its own aren't useful for us, so we have to make them useful for us. And since we have our data in so many different places and so many different storage systems, we need a process, a workflow to extract the data into a single place, and in order to do our analysis. So if we look at a small scenario, let's say we have a small company, a SaaS company, and we have a few years of operational data, and we are not making use of anything. So we are not using that data for anything. We are just collecting it in our logs and our storage systems. So, and let's say we have a web application, a mobile application, and API. So our logs and our customer insight data everywhere in those three places. And business, after so many years, we decide to take some actions using that data. And let's see what are the processes we need to take. So first of all, we need to extract and load data into a single place. And if we have log data, I don't think they make much use for us without our user data and our other marketing data to correspond those logs. So we need to extract all those data into a single place. And then, so some of data can be in different formats. Some might have undefined values, some might have null values, different formats, different columns, and some might not even have columns, so no SQL data. So we need to clean and transform those data to data that can be useful for us, that we can take actions on, and we can take some analysis queries on. So that can be our next step if we are going to use that data. And after we extract, clean, and load those data, we need to do some analysis and run some reports and do some business intelligence on those data. Then only those data can be useful for us. Then let's say we did that one time, but after a month or so, we decide to do some analysis again, and we run that steps again manually. But those workflows we can't do them manually always, right? So we have to automate it. So after we know that we can use our data, we can automate that process. So if we take a hypothetical scenario, I think those 4 steps can be the path to make our data useful for us. And how we are going to use those data, that's where Azure Data Factory comes in. So we can use Azure Data Factory to do all those steps I described above. And Azure Data Factory, that is a cloud data integration and transformation service. So that Azure Data Factory can cloud-based extract, transform, and load services and do some data integrations within the service. So we don't have to have on-premise system. So if some of you guys might know that there are systems such as SSIS, so we run some analytics on those SSIS services, and that is Azure Data Factory is something like that, but hosted on the cloud. And we can have complex ETL processes in Azure Data Factory, and we can even call other external services from Azure Data Factory, such as Databricks, HDinsight, or the newer Synapse Analytics. And using those steps, we can have data-driven workflows. So if you guys can remember the workflow we talked before, that we can implement using Azure Data Factory, and we can automate it. And so using that, we can orchestrate our data movement within all those different places and transform our data. And one of the best things about Azure Data Factory is it is codeless. I mean, if you can code, you can code the data factory, of course. But for someone who doesn't know coding much, Azure Data Factory has a GUI designer, so you can design all your data-driven workflows from a graphical interface. And since Azure Data Factory is a cloud-hosted solution, we can scale that as much as we want if you are paying the price. And of course, we can automate. And one of the best things about Azure Data Factory is if we have already implemented SSIS packages in our organization, you can just export them and use them within the Azure Data Factory without doing any modifications. So you just have to configure your new on-premise data or other data connections, and you can just use that SSIS package within Azure Data Factory. And Azure Data Factory is serverless, as in the meaning that it is only built for the hours we use. So it is cost efficient, and we don't have to worry about managing any servers since it is fully managed. And we have CI/CD integration within Azure Data Factory. We'll talk about these points in detail in the coming slides. So you can run Azure Data Factory activities within your CI/CD pipelines, and you can do some incremental updates to the pipeline and do some data management. So how does this all work? So there are few steps to use Azure Data Factory, but I have boiled them down into you have to ingest your data and you have to transform, and you will need to CI/CD and publish those pipelines, and of course you need to monitor. And if we go one by one in these points, when we are ingesting data, as we talked before, we can ingest from multiple data sources. So your data sources can be on premise or in the cloud. They can be unstructured, structured, or even semi-structured. So your data can be of any type, but you can ingest those data. And those data connections can arrive in different speeds. You can refresh them daily. You can refresh them manually, or you can stream those data. And so if we talked about a manual scenario, if we you'll have to implement any custom data movement components if you don't have Data Factory and collect those data into a centralized data store. So Azure Data Factory is making that data movement easy for you. And you can even use Azure Data Factory to copy your on-premise data into any Azure SQL services, and you can use them in your transformations. So we don't have to use our old OLTP databases for our analytics. You can build a OLAP database and do your analytics. And after you ingest those data, you can send them to a centralized data store. So that can be a Azure data lake or a blob storage for the further analysis. And the next step would be transformation. So once you collect those data, you can transform those data using data flows. So these data flows can be mapping, wrangling, and you can use, as I told before, your existing SSIS packages to transform those data. And also you can use a Hadoop, Spark, or other external activities that's hosted within Azure or any other cloud provider to analyze your data. So Azure Data Factory transformation is not limited to what you can do within Azure Data Factory. You can use activities for external services and transform your data. And we have Spark inbuilt in the Azure Data Factory, so you can use some inbuilt transformation. So you can write your custom Spark code within Azure Data Factory to transform also. And Azure also has some Azure machine learning and other services. You can even call to Azure machine learning activities to transform your data. And of course, these can be code free, or you can use any SDK to transform. And after we run any transformations, and so we already have our pipelines, you'll need to monitor, no, before the monitoring, you'll need to CI/CD and publish those pipelines. So to publish, you can use Git, GitHub, or Azure DevOps. So you can manage your Azure Data Factory pipelines as JSON files within your Git. So you can create branches and create different versions of your pipelines and test. And you can use your CI/CD pipeline to integrate them into a final production data factory and run your workloads. And once we have our pipelines running, we can monitor our pipelines. So without monitoring, so our data factory pipelines, if they are failing, we wouldn't know. So our business processes they can be hindered, or they will be inefficient. So we'll need to monitor our pipelines if they are running correctly. So to monitor, you can use Azure Monitor. So since it is integrated in almost all Azure services, and you can even use Azure Monitor alerts. So you can send yourself or other teammates an email alert or something if your data factory pipelines are failing. And also you can have diagnostic logs uh, of your data factory pipelines into Azure Log Analytics, and you can stream those logs. So you can stream those logs into a storage account or into Power BI and do some widgets, or you can use Azure Event Hub to send some events if in a success or a failure, and you can monitor your pipeline once you create it. So yeah. Do you guys have any questions up to this point? I think I hope you guys got an idea about what Azure Data Factory is. Okay, so after we publish our pipeline and if it is running correctly, uh, that we can monitor and do some analytics. And let's see. So before building our pipelines, we'll have to know what are our components, what can we use to build our pipelines with. Let's go some high level analysis into our Azure Data Factory pipelines. Let me share my Azure portal with you guys. Okay. So if we go into the Azure portal, we have Azure Data Factories. And you can go into Author and Monitor to create your Data Factory pipelines. Okay. So the basic building block of a pipeline is an activity. So activity is a single processing step, but that you can use to create your pipeline. So if you can see, there are different activities that you can use to copy data and trigger data flows. And you can even have control activities in the pipeline. You can call a pipeline from another pipeline. So that is the basic building block of a pipeline. Then we have pipelines. So a pipeline is a logical group of activities. So you can group some activities together and run your pipeline. So they can be independent, and you can run some pipelines in sequential order, or you can run those pipelines in parallel. And then we have control flows. So like I said, we can run pipelines in a loop if you have multiple data sets, and you can use control flow to orchestrate your activities and pipelines in the way you want to run. You can even use branches and conditional executions for the pipelines. And we can use parameters and variables in the pipelines. So we have different variables and parameters. You have pipeline scope parameters and variables. So you can use those variables to pass data between pipelines. So you can have a variable name called table name, and do some pass that table name into different pipelines, do some different activities. And yes, so the data set, that is a representation of our data that we are going to ingest or digest in from our pipeline. So we have a data connection, and that connection is represented by a data set. Then we have linked services. So using linked services, we can create connections into our Azure Data Factory. So if you can see, we have already a Cosmos DB and SQL connection, and you can have different types of connections for the Azure Data Factory. You can use these connections to ingest your data or do the output from your pipelines. And we are going to use data flows to do our transformations. You can have multiple steps and multiple sources in different data flows, and these data flows will do your transformations. So in these steps, you can create your analysis pipelines. So using these data flows, you can call to stored procedures or Databricks, any other external services like I said earlier. And then we have integration runtimes. So we need an integration runtime to run our data flows. So there are different integration runtimes. So one is Azure hosted one, or else we can host a integration runtime in our on-premise servers. And if you're going to lift and shift SSIS packages, you'll have to use Azure SSIS integration runtime. And we can also debug our Azure Data Factories, Data Factory pipeline. So if you can see, there's in the data flow debug button. So if you enable this, you can debug your factory pipelines. So in a pipeline, you can set a debug point and debug it. So we can even see some data previews. So if you have multiple activities, you can see what are the data passing between activities in those pipelines using data preview. And for triggering our pipelines, we have we can trigger our pipelines on demand using any API call or SDKs, or else we can schedule our pipelines to run every midnight or in a wall clock schedule, or we can use some events to trigger our pipelines. So that was a basic introduction for Azure Data Factory. I hope you guys understood. And if you have any questions, please feel free to ask since we are a small set and this is a webinar. And after this, we are going to show you a small demonstration on how to build a dynamic data pipeline using Azure Data Factory, and Sameendra is going to demonstrate that for you. Over to you, Sameendra.
We can't hear you, Sameendra. You are muted.
Yes. All right. So good evening, everyone. I think I'd been talking a bit, but no one heard it because I was muted. Anyway, let's start off with creating a data factory. So as you all can see, we actually have one data factory already created, but we'll try to redo the same thing and walk you all through creating a small data factory. So if you go into data factories, you can pick the subscription and you can create one. I will give it a name. You can pick or create a resource group. With the default location, I guess. And so this will hopefully take about 30 seconds. All right, cool. So we can go to resource. And as Dishan demonstrated, you can click on author and monitor. And if you go back, there's a whole documentation link as well. So this opens up a new application for the data factory. And here you have the navigation between the home, author, and monitor icons. So when you click on author, or you can click on create pipeline over here. So we'll sort of create our first pipeline. So you guys should know that this is very graphical and really easy. Nothing much to actually understand, just to get the idea. So you can give this pipeline a name. Let's call it product suggestion pipeline. Let me show you why I named it product suggestion pipeline, because I actually picked a use case of suggesting products. Let me move into it in a bit. So here, so you can actually see all the activities that you can have in a pipeline. So you can have copy data, data flow, and you have these various Explorer functions, and you can even integrate Azure functions and Databricks, data lakes, general stuff like the pending a variable, execute another pipeline within this particular pipeline. And if you want to execute an SSIS package, and even if you want to look up a table or a specific column, let's say, likewise, and you have these various stuff. But for the demo, we'll actually be discussing a general use case that we most of will probably come across, which is suggesting products based on the location, let's say. So this is actually the database that I sort of replicated in Azure instance. So this is the ER diagram of the database. So basically it's an online shop. So where you have suppliers and where you have products, and then you register customers, and customers can create an order, and orders have order items of products. And I have actually I took ran some scripts from this and populated a fair amount of data as well into the database. So this is actually out of scope, I guess. Now the database is already created. So what we are going to do is, let's say, so this shopping online shop needs to prompt the users with suggestions based on a user's location. For an example, if a user is logging in from UK London, so the suggestions of the products that they're going to be listed with will be the most popular in that particular area. So let's say that's the use case that we are going to deal with. So what you need to do is you will actually have to join these tables to get a frequency of ordering items grouped by their customers' locations, for an example, or rather city and the country. So I think you all understood the idea of the use case that we are trying to develop, and we'll be and this will be an SQL Microsoft SQL database hosted in Azure. So it's an SQL Azure server, and we'll be copying the suggestions. So we'll be creating the suggestions and copying them into another Cosmos DB instance in again Azure, so that you will get an understanding how we can work with different services, not only within Azure but also out of Azure. But we won't actually be using any of the services out of Azure for now. But you can of course use the more like a lot of services that they support in that. Yeah, I think you all understood the use case. Any questions on that? The use case, the scenario that we are trying to implement. I think you all understood the question, or rather the use case, so I can hopefully continue. So the first step will be creating some connections to these data sources and targets. So in the Data Factory, they are called the linked services. So you can add a new linked service. So as the source, what we'll be using is an Azure SQL server. So you can search for, before that, let me show you some of the services that you can actually use. So there's Amazon Marketplace, Web Service, Redshift, Amazon S3, Azure Blob Storage, Cosmos DB, MariaDB, even Azure Key Vault, SQL databases, table storage, Couchbase. So there's quite a lot of services actually. So they are not the services which are of Azure, but also outside of Azure. So there are compute instances like this as well, which you can link. And so this lists all the services, and there's a filter over here. So we'll look for Azure SQL. So we'll be linking an Azure SQL database with our service. We'll call it the byme.com. And so you can pick the database, or you can either use the connection string and enter all the login credentials manually, or you can even use the Azure Key Vault. For now, I'll just be picking it up from the subscription itself. So the server name is webinar sample, and we have a database, the one that I have created earlier, byme.com, and we'll be using SQL authentication. And this step also, you can still use Azure Key Vault for password without storing it inside the data factory itself. So let me I just added the username and the password there, and we'll test the connection, and hopefully it will be a success. Yes. Then you click on create. All right. The target I'll create. We can create it later as well, but we'll create it then and there since we know what we are doing already. So we'll be using Azure Cosmos DB SQL API. So we'll call it the suggestions DB, and then again for the connection string, I'll be picking it up from the subscription itself. At any point, make sure that you'll interrupt me and ask questions if there are any. So we'll test the connection. So the connection to the source database, the target database is also a success. So what we are trying to do is get some data of this SQL database, byme.com, and then transfer them or do some computation in the middle. We transform that data and update the suggestions DB with that transformed data. All right. So we can we'll have to create a couple of data sets to use in the data flows. So I'll be mapping the tables in this particular database, the source database, into a few data sets. So I'll be again searching for Azure SQL. All right. Continue. So we'll call this the customer, or let's just pick the service first. And then, so here it lists you the created link services. So you can pick one from it. So at this point, if you don't get any of the link services, which means you don't have any created yet, so you'll have to create them first. So we can pick a table name. So it lists all the tables over here. So I'll click on the customer table, and I'll be importing the schema as well. So I'll give the dataset the name customer, and we can click on OK. And if you go to this dataset, you can actually see you can even customize the you can even customize the what you actually want to do, and you can even add a dynamic content. So we'll just keep it as it is for now, and you can even preview data and see what's there in this particular table. So this is a chunk of data, what's in that particular table. So I'll be doing the same for others as well. So let me quickly create a couple of other data sets as well. Azure SQL. Okay, and I'll be picking the link service by me.com and order. Okay. All right, another one. So we need order item as well, and we can call it the order item. All right. And then the one. Product. So we won't actually be needing the supplier table because we won't be actually dealing with any of the supplier details for a particular product. So we have the data sets in order now. So let's get to the step where we create the data flow. So this is where actually the transformation happens. So we'll be joining these tables and creating a suggestion. So when you go into the data flows, or rather creating data flows, you get to create, or you have the option of creating two types of data flows: the mapping data flow and the wrangling data flow. So here, what it actually do is you do a code or rather data transformation. So you can, as it suggests, code-free data transformation at scale. And for the wrangling data flows, actually you use it to prepare data. Let's say you have to cleanse or prepare data. You'll be using the wrangling data flow. And so the use case that we do or follow today is more of a transformation. So I'll be picking the option mapping data flow. Okay, and start by adding source to data flow. So you can have as many sources as you need, and these sources will always be a data set. So you can see, you can give it an output stream name, and you can pick a data set. So let's say you can, we'll name this the we'll say the customer. We'll go in order. The output stream name would be customer, and we'll be selecting the customer table. So meanwhile, we'll click on this data flow debug, because what it does is, as you could remember, if you could remember, Dishan showed you something called integration runtimes. So that is actually the computing instance that this transformation happens. So even to debug, it spins up a new instance of a runtime. So it takes somewhat time. So we'll keep it on. So by the time we are done with some stuff, it will be up, because it takes about 10 to 15 minutes sometimes to spin up an instance. All right. So here you have few options. You can allow schema drift sampling likewise. So most of them will not be used in most of the cases. They're just if you do really advanced stuff, they are needed. But for us, we won't be messing with any of those options or settings. So here is something important from the data set. Also, you can either import the whole data set or you can have a custom SQL query over here. For an example, select, let's say, whatever the columns that you need. So only those columns will be shown or projected in the source, output of the source. So I'll show that to you in a while. But for this, we won't be using a query, but we'll be importing or projecting the whole table. So here you can see the projection. So what the columns are. And you have these optimizations for partitioning, and you can even have a data preview. So the problem here is we can't preview any of the data until the data flow debug starts. So we'll create the other sources meanwhile it starts. It actually starts. So we'll add another source called order, and we'll pick the data set order, and we'll keep the rest as it is. Again, order item, oops, product. We'll be using the product data set over here, and yeah. And so the next step would be we'll have to select, as I said, you can select the columns in the query, or there's an option where you can sort of select. So there are when you click on this plus icon, you can pick what the next step of the data flow is going to be, or it would what it would be. So you can have there are options to deal with multiple inputs, outputs, and if there's an schema modifier that you need to do, there are schema modifiers, and there are row modifiers, and the destination, the sync step. So here what we'll be doing is we'll be doing a schema modification which will be selecting only the columns that we are going to need. So for the customer data set, we'll call it the output stream name would be customer columns, let's say. And here it shows you a map of the mappings, all the mappings. If you see, you can use auto mapping, or you can customize the mapping and pick only you need. And you can, if you are doing it manually, you can add mappings as well. For now, we can't add a mapping because it will be then again an already done mapping. So we'll delete it. So from this, what we'll actually need is going to be the customer ID, the city, and the country that this person is living in, not any other detail, because we won't be dealing with any of the names, because when you do a suggestion, you don't show who actually bought this, the person's name. So we don't need that. And then we don't need the last name. We don't even need the phone number. So it will only be the city and the country. And for joining, we'll be needing the ID. So we'll name it as customer ID. So you can even alter the column name when you go along the flow. So if you now you can see the debug instance is up, so you can actually preview the data. So there are debug settings as well. You can set the source datasets raw limit over here. So we'll save it, and it will show you if there are any parameters that you need to set before you use this data flow for debug. So when you refresh, I'll actually show what a parameter is in a bit, hopefully. So it's going to fetch data and from the data set, and it will filter the columns or select the columns that we only need and show it over here. All right, cool. So here you it lists the customer IDs against the city and the country that the customer is from. So we'll do some of the same for other data sets as well. So we'll be selecting the columns. We'll call it the order columns. And from the order, what we are going to need is the customer ID. We won't be dealing with the total amount. We don't need that. We don't need the order ID. We don't need the order data as well, because we don't do any date-based aggregation on this. All right, so we have the customer ID and the order ID. So we'll rename this as order ID because there's going to be a lot of IDs involved in this. So if you go to preview and refresh, it will again show the orders. And meanwhile, I'll the same for this. Select order item columns, and we will only need the mapping between the order, original order. So we don't need the unit price and quantity, but we need the product ID, the order ID, and this order item ID. So we'll keep those with us. And then you have the product. We'll do the same for the product as well. Select. We'll call it the product columns. So from the product, we'll be needing this property to see if it's discontinued or not, because there's no point in suggesting any of the items that are discontinued. So we'll need that, and the package we might not need. The unit price we don't need. Supply ID we don't need. Product name and the ID will be needed. We might not need the product name actually, but if we are to query the product based on the ID, we actually don't need the product name. But for the demonstration, we need the product name so that you can actually see what this particular product is. All right. So then what we'll be doing is several joins. So I'll be joining all these tables together to sort of create a flat table and do an aggregate on that. So we'll first be joining the product and the order item. So I'll click on the plus and select join. And from this you can give it a name. We'll call it order item product join, and you can pick what the left stream of the join is going to be and what the right stream of the join is going to be. So as per the right stream, we'll be using the product and not this particular step, but this particular step as the right stream. So you have to pick product columns. So here you pick product columns, and you can pick what the join type is going to be. So we'll be joining, we'll be doing an inner join, and it has this nice representation of how the join is going to be. So we'll only be taking the intersection of both the tables. And you can specify the join conditions. So we'll be joining the two tables, the product and the order item table, based on the order item tables product ID and the product tables product ID. So we'll rather rename this the product ID instead of ID. Product ID, yeah. So now you can see, yes, it has changed to product ID. So if you go and refresh, and we have this step selected, order item product join. So it will show all the joined data. So what it will do is it will basically show all the products that are there in all the order items. So you can see the two tables are joined now. And from the product table, actually, I forgot to do filtration because I told you we don't need any of these fields which are actually discontinued. So we don't need any of the discontinued fields. So for that, either you can specify it in these steps source options query. So you can filter out any of the items using a query. But why bother? So what I'll do is I'll just use the filter step, and what I'll do is I'll filter out filter discontinued items, or rather products, and incoming stream is going to be product columns. And from that I'll be filtering based on so here this is the visual expression builder. So here you have almost all the SQL functions this is actually changed based on what your source is. So in this case we'll be using an SQL table as a SQL this as the source. So it will list almost all these functions. So here what we actually need is the is discontinued. We'll be filtering based on that. Is equals to false. So we don't need, we want to filter out based on this particular condition. From the schema, we pick this is discontinued column, and it needs to be false. So we save and finish, and it will actually show you an error if there's a problem with the expression. See, the column not found, which is not the case actually. It's this. So you save and finish, and if you do a preview of this, you refresh, and so you can see now the is discontinued field is false. So all the data here listed here are filtered data, which the discontinued field is false. All right, so now we have all the products which are not discontinued. So now there's a problem with this. We did the joins right stream actually with this particular step, which is the product columns, but we need to change it now to the right stream to be this this particular step. So what I'll do is I'll go into this step, go to join settings. I'll change the right stream to filter discontinued products. All right, filter discontinued products. All right. So now what this is going to have will only be the still available products. Guys, any other is there any question so far? Anything to ask? All right. So now you can see, so it doesn't have any discontinued products order. So here it will show all the orders that are made on still available products. So then we'll be joining this, or rather we'll join these two first. So I'll do a join on customer and order, a very similar join. So here what it's gonna be is customer order join, and the left stream will of course be customer columns, and the right stream will be order columns. Right, order columns, and then we'll pick the condition. So the left stream, the customers will be the join will be based on the customers tables, or rather customer datasets customer ID, and the order tables customer ID. Sorry, the product, right? Oh, sorry, order ID. So what we'll be doing is we'll be joining the customer dataset and the order dataset. So the output will be the customers of all the orders, or the otherwise orders of all the customers. So again, it will be an intersection or an inner join. Oops. Sorry. So here it has to be customer ID. I think I have not picked customer ID. So this is there. Sorry, this is the order item table. So I have picked the wrong right stream. It has to be order columns. This one. All right. So now you can see. So it actually graphically demonstrates how the join is going to be. So I'm joining these two steps. So so the customer ID will be on this one's customer ID. All right. Cool. Now we can see the preview of that as well. So you'll be able to see the country and the city of the customers who ordered something, basically, or rather the customer ID and the place that they live in for all the orders that are made ever. So you can see the customer ID, the city, and the order ID. All right. So now the next join will be these two fields. So we'll be doing another join based on this. We'll call it the customer order item product join. Confusing name, but that's what actually happens. So left stream is going to be customer order join, and we'll be joining. Let me minus this a bit so that you can sort of clearly see it. So we'll be joining this step with this join. So we'll have to pick the order item product join. So now we can see Usually see this is this, and it's joined with this. And again, it's going to be an inner join. The fields will be the join of this is going to be the order. The condition will be the order number actually. Yes. Order columns. I think I sort of made a mistake. It will actually be easier if we do the join between these two and do it otherwise. So what I'll do is I'll just join the order table with this. Otherwise, it's going to be a little bit confusing for me as well. So this join is going to be the order item join. Order item join, and the left stream is fine, and the right stream is going to be order item product join, and it will be based on the order ID of both the sides. Order ID, and from this also order ID. Right. We have the relationship between the order item and the order. From the order only we are going to make the relationship to the customer. So I'll have another join. You can see the fields. So in this join, what I'll do is I'll order item join, order item customer join. This is going to be order. Oops, not that. So this order. Let's say order item. Okay, it's already just delete this step. Join the item. Order item. Fine. And the fields are going to be customer ID, and from this also customer ID. Yes. All right. This should have. I think this will have all the fields that we need for the aggregation or grouping. So we have product details and order details and customer details together. So now what we are going to do is we'll be aggregating this data. So in a schema modifier, we pick on aggregate. So in this, what we'll be doing is group product customer, let's say. So we are going to group this by the city, the country, and of course the customer ID. Yes, and in this we'll be counting the customer ID to know how many customers in this particular area actually bought bought products. We'll just count, and from the input schema we'll have customer ID. Or even we can make it actually the product ID, or how we need to know how many products were actually sold in this particular area, and it will again be some other same how many customers that actually bought this item from this particular area. So you can actually pick any of them depending on what suits you the best in this particular scenario. So if we do the aggregation and we do, oops, there's some errors. I think the problem is we'll call it the frequency, the buying frequency actually. Yeah, we'll try to do a preview, refresh. Now you'll be able to see the fields. We are almost at the end of what we are going to do. Yes, now we can actually see yes. So I actually did a mistake in the aggregation here. What has shown is actually how many customers have visited the site in this city, in this country. So it's 9 times, and this is 13 times from Germany, Munster. Likewise, so in the aggregate function, what I should actually do is instead of this, we have to have the product ID column. You should count the product ID, schema, product ID. Yeah. And there should be another grouping based on you should have to you actually don't need the customer ID. It should actually be the product name and the product ID. Yes. All right, so if we go into the preview, now it will show the products and their IDs grouped based on the purchase location, the country and the city. Are you all confused to sort of understood? I think I would ask that question because I also got tricked a couple of times. Is everyone okay? Guys? Yes?
Yes.
Yep.
All right, so I think hopefully I can continue. All right, now you can actually see the products, the product IDs, and their buying frequency based on the country and the city. So that is what I actually wanted to do. So I wanted the number of buys for a particular product based on its buying location, the country and the city. So that's why I did all these joins. So afterwards, what I would need is just to have all these details transferred into a Cosmos DB. So if you want, you can have something called a surrogate key, which means an ID for each of these columns. So you will call it an ID column. So the key column, we won't need the start value, we will set it as 1, and if you get a preview, all right, so you have to have a key column. We'll call it ID. This is basically the name of the column. It's to add. So if you do a preview, now you see the ID field as well. So you can even add columns to your data. All right. So now you can see the ID field as well. So the final step is going to be this is not enough to just to work these out, but to save the data. So the save step is actually called the sync under destination category. So when you go into sync, you can call it sync suggestions, just another name. Incoming stream would be this, and you can pick then again a data set. So in this time, what we are going to do is we'll have to create another data set. We won't be saving this to any of these tables, but instead we'll have to have another data set for the Cosmos DB database we have. And that is SQL API, and the link service is suggestions DB, and we'll call it the suggestions. And for this, you have to pick the collection for Cosmos DBs. Yes. All right. Okay. Now we'll go back to the data flow. We'll actually give the data flow a name. Settings. Sorry. Sorry, the properties are here. So the data flow name, we'll call it create suggestions data flow. Yes, we'll go into this and we'll pick the new data set that we created, the suggestions data set. Yes, you can have a look at the data. But this, when you do a preview in this sync step, it doesn't actually upload or copy or export the data into the database. It will just show a snapshot of it in the preview section. Yes, so this is actually a sample of the data that is going to be saved into the target database. So now we have done creating the data flow. Let's say now how are we going to run this data flow actually. So here what we'll do is we'll just drag this and drop here. There you go. So now when you run this pipeline, what actually happens is it will create it will just run this particular data flow. So if I talk a bit more about the pipelines, you can have other steps like for an example, if you have a lookup instance where you look up some data from a table, and you can execute this data flow based on the lookup data. Like you sort of can pass this data into this data flow and execute it. So when you click on this, you can actually set you can execute the next activity on its success, failure, completion, or skip. So this is the green. So this step will be actually executed after this particular activity is a success. So if you want to let me just quickly create a parameter in this as well, so that you can you know that you can actually pass data. So you add here, let's say we deal with multi-tenancy. So here you do the same thing for every tenant in your system. So we'll call it the tenant, and you don't have to have a default value. So if you go back to this and you click on the data flow, we are in the pipeline now. In the settings section, the parameters section, you can actually see the tenant, the data flow parameter, right? So you can pass in a value, like you can either hard code a value, or you can pass what is the output of this also. So for this, we actually don't need a lookup step. It will just be the mapping data flow, and you can actually debug this and see and validate. Oops. Okay, so it shouts at me that there's no value provided for the parameter tenant. Since we don't need that, we'll just delete that parameter. We'll go into this, and we don't need this, delete. Go back. It was just to show you that you can actually pass in data into a data flow from the pipeline also, other than looking it up from the data flow itself. So here, when you try to run this, you can do a quick trigger, or you can have a trigger, something called a trigger. So you can actually pick an existing trigger, or you can create a trigger. It can be a tumbling an event, one-time event, or a schedule that runs every recurring event. All right, so we actually don't need a trigger for now. So we'll just run this and see, but before you run, you have to publish the pipeline. So I'll click on publish. So these changes will be published. And yep, I think it's still publishing. All right, publishing completed, and we'll add a trigger now. So it will show if there are any parameters that you need to pass in before triggering. Since we don't have any, we'll just trigger a run now. And by clicking on this, you can actually monitor the pipeline runs. So you go into this. So this is the pipeline which is in progress state now. When you click on it, it lists all the activities, executed activities and their states, and what's being passed as data. So you can see these are the datasets that are being passed, and even you can see the output of this particular step after it's being run. And since this is a data flow, you can actually see the data flow details when you click on this. So now it's acquiring a compute. This is actually, it doesn't have any dedicated computing instance. What it does is it just creates a new instance. To be exact, I think Azure Data Lake instance to run this data flow on. And until it's up, it just hangs like this. So it will take a couple of minutes. Meanwhile, I can answer the questions up to this step. And once this is done, I can actually show you the results in the suggestions Cosmos DB. Yeah, so that sort of wraps it up. Very quick session. I think I had to rush through because of the time. I think almost 30 minutes late than the scheduled time, but I think you all got something. So any questions to any of us, Dishan or me?
So if we, I think we missed something. So if we talk about the pricing a bit, so you
Yeah.
get charged for the activity pricing. So it's like 1,000 activities is around $1 per month. So the number of activities in your pipeline and the integration runtime is matters for your pricing.
Yeah, so you can actually have what actually costs is not the pipeline runs, but the integration uptime. So it's actually a computing instance where it spins up for these pipeline runs. So you can see you can have 1,000 activity runs per month per $1, and for SQL Server integrations, it's $0.8 per hour. But what actually costs is now you can see this is actually running on an instance, a computing instance. So it costs, I think, per every minute of that instance is up. So if you go into integration runtimes, we are using the default Azure hosted runtime. You can actually create new runtimes if you want. We go into this author and monitor, go into this. Here you have integration runtimes, and you can actually add a new integration runtime and add this as per each for your pipeline runs. So it will use this particular instance of this particular compute instance instead of the auto resolved instance. So you can actually configure this to type yes. Here you can make it either general purpose, compute optimized, memory optimized based on your requirement. If you have very memory consuming tasks, it's better to pick this up. And you can have the core count up to 256 cores, which is going to be really, really expensive, of course. And the time to live time is also important because let's say you have a recurring pipeline and with a data flow in it. So each time if it's to spin a new instance, like once it's time, let's say one pipeline runs and it uses a computing instance, and once it's done, it shuts itself down automatically. But then again, you have to up another one for the next time, next iteration of a loop of the pipeline run. It takes another couple of minutes. So to avoid that, you can set a TTL, time to live, up to 4 hours, so that it stays up. But be careful, you will be charged for that uptime. But then again, it fastens things up if you have pipelines in a loop, in a control loop. So it won't try to spin up a new kill an instance at the end of an iteration and try to spin up a new one in the next, at the start of the next iteration. It will avoid if you set it to like 10 minutes or so. So that's the idea of integration runtimes. So let me go back to the monitoring part. It's still in progress. So it has run for 6 minutes now. Any more questions? We'll be done in a couple of minutes, I guess. And of course, if I'm to talk about the use case, you would have thought, why don't we do this? Just do this in SQL itself, like as in a query. So two reasons is I did this example as it's one of the simplest to think of as a use case to use for a data flow. Or rather to use in Azure Data Factory. The other is, let's say it's a big online shops like let's say infamous Kapruka or Amazon or something. So if you have to do a query on all the order details, like all the order items, and do such level of joins, it's going to take a lot of your servers resources, the database servers resources. So this is totally offline, so it won't consume any of your database servers resources other than querying, of course. And query is also not very complex. It will just take all the whole table out of the DB and do all the computation within the instance itself. So this is a good way of doing it if you have very time consuming or resource consuming processes, and which needs to be scheduled or run off your database server, even if it's a simple, like something that you can achieve with simple SQL queries. Yeah.
So even if we want to avoid that querying part from our OLTP, we can have a scheduled run to copy our OLTP data into another database for our analytics. So we can avoid that overhead as well.
Okay, it's running. Won't take long, I guess. So this is like the really basic scenario, but you can do a lot more things on this. So this is just a very minimal introduction. If you are completely new to Azure Data Factory and to know what it is and what is actually possible with it. But there's a lot of more things to do with, as Dishan mentioned. This is more useful in if you take big data and such domains.
So even in Asia documentation, they mentioned that you guys might know AccuWeather. So that AccuWeather, they do their predictions using Azure Data Factory and Azure Machine Learning. So they have a pretty interesting case study in Microsoft customer stories. You guys can go ahead and read it to see how other professional organizations are using Azure Data Factory.
Right. Not sure why it takes so long. Almost 10 minutes. Any more questions? Maybe we can answer meanwhile from anyone. Is it useful at least? Because I felt like I was rushing very fast. No questions from anyone? No one.
I think we got an overall idea about how to use this Azure Data Factory and with a use case as well. So I think yeah, it's a great presentation. So we got the full picture of it, how to use it in a scenario like this. Yeah, that's from my side. Yeah.
I think since this is taking a while, maybe I can show
I
you.
think it is succeeded, Sameendra. You can refresh the page and see if it is. If you do a page refresh, it might.
Yeah.
So I can see if it succeeded in my.
Are you referring to the previous one that we created?
Oh yes.
Maybe that. Yeah, actually the previous run, maybe without waiting, I wanted to have the real billing, but we ran it before. So I think if it has not messed the data yet on the new run, we already have some of the data. This is the Cosmos account that we have created, and in this we have the product suggestions container. And if we go into this and try to query, so it will show you all the suggestions that it has created. Now let's say there's a customer logging in from Brazil. So all you have to do is your query is going to be not all that join, but to this Cosmos DB, selecting all from C, where C dot country equals Brazil, and yes, it will show all the suggestions. Let's say we'll include the city as well. Let's say now a particular customer has logged in from Brazil, and from he has mentioned his location or address as Rio de Janeiro. And what you can do is make a query to this and order by frequency. All right. So if you run this, Oops. You can actually see all the products and their top frequencies board from this particular location. So if this person is logging in this from this location, so it shows you the suggestions, the location based suggestions, or what other people has, the products that other people actually bought who lives in this particular location, and their frequency as well. So like you can actually sort it depending on the frequency. So Style Stout has been bought 3 times from Brazil, Rio de Janeiro. And the second most, again the same, whatever blah blah this is, which is again bought from Rio de Janeiro, Brazil. And all these are, okay, this is the second most bought item. Carnarvon Tigers, I don't know what that is, and again from Rio de Janeiro, Brazil. So this is actually sort of a data mining job that we did. We use something very similar in Compelo as well to give out suggestions to the users depending on their or based on their history, the usage on their, let's say, the invoices. In our case, we have an accounting system. So based on the past invoices, we give them some predictions or suggestions using. So the underlying technique is actually Azure Data Factory, and a very similar approach. Yeah, I think if you don't have any further questions, we can sort of wrap it up. Or you can just throw questions if you have any. Anyone?
We have a very silent audience, it seems.
Yeah. Either they, as the classic saying, they understood everything or understood nothing, I guess.
Hopefully, it's the first. I think the reason why that our current pipeline is taking so long is its cluster startup time has taken almost 10 minutes. So
yeah, maybe. So let's see if it, okay, let's refresh it now. Okay, it still runs.
yeah. So
No,
these things happen from time to time. So from because of the COVID-19 as well, because Asia allocates their resources depending on the region and the way our customer subscription is. So there are some Asia restrictions as well these days.
okay, this is still running. All right.
So
anyway, that's fine, I think.
yeah. So we'll anyway share the meeting recording and also the the whatever the things we discussed, and also the slides with the in the meeting, the request. So if you guys have any questions or anyone want to implement Azure Data Factory, so I would recommend to just get a do contact Sameendra or Dishan. Is that okay, right, guys? So you
Yeah,
guys
that's
can
fine.
help out anyone.
Yes,
Yeah.
of course.
So yep, thank you very much, Sameendra and Dishan, again for that insightful session on this. So hope to see you guys in the next coming sessions as well. Thank you very much, everyone, for participating and staying at us with for such a long time than scheduled. So thank you, everyone. Have a nice day then. Okay.
Yes, have a nice day,
Bye.
guys. Thank you very
Thank you,
much.
guys.
Bye.
Thank
Okay.
you
Bye bye.
guys. Thank you, Sameendra and
Thank
Dishan.
you.
Thank you.
Bye.
Thank you guys. Bye.
Thank you guys. Bye.